something sinister.
The dark side. It pulls at him.
What if the answer to the search for extraterrestrial life has been staring us in the face all along? In fact, what if it was right here in between us, but we just can't see it? You might not be familiar with dark matter, and that is because it is something that we cannot see. But dark matter, in theory, is a foundational building block just like normal matter is. If all the stars are made from matter, as well as the planets and people as well, are made of matter, that must mean one thing. Dark matter is an equal force that creates all that's mentioned as well. The only difference is, we can't see it. Dark particles, dark stars, dark galaxies, dark planets, and eventually, dark life. Today we're going to talk about the mysterious but most intriguing aspect of our entire universe that's been having scientists chasing around it since the early 1900s. Now, before we get into the subject, it is important to point out that everything about dark matter is purely theoretical. Scientists have no concrete data about the mysterious element, and no one even knows what it looks like. Even though it is the most hidden subject in the universe, we can still get an understanding of it by comparing it to other things that we do know about. Let us first look at normal matter. In simple terms, matter is everything you see. Atoms, stars, galaxies, planets, trees, rocks, and people. Dark matter is everything we don't see. In fact, the vast majority of the mass in our universe is invisible. Matter makes up less than 5% of the known universe, while 25% is dark matter, and the remaining 70% is made up of dark energy. Everything we know is minuscule in the grand scale of the vast expanding universe. Although we don't know anything about dark matter and dark energy, we are pretty sure that they exist. How do we know that it exists if we don't know anything about it and we don't even know what it looks like, you might ask? Well, no one knows what it looks like because it can't be seen, not even with telescopes or different lights that we know of. Any visualization of dark matter is purely theoretical or autistic creativity. In fact, the only reason we're sure of its existence is because dark matter makes it possible for planets and space as a whole to exist. You see, there just isn't enough normal matter. Its gravity isn't strong enough to form entire galaxies and complex solar systems and keep them together. Everything would be scattered all over the place. The only logical conclusion is that there must be something else at play. Another force holding the fort. One that doesn't emit nor absorb light. It is completely dark in all of its meanings, hence the name. How do we know it's there? We ask again? Well, places with a high concentration of dark matter bend light in an unusual way. That means that there is something there that is affecting gravity, presumably dark matter. We know what dark matter is not what it is. Hence, we can deduce what it is based on the process of elimination of what it is not. It is what it is. It's not normal matter because it would emit particles that we could detect. It's not antimatter either because they produce gamma rays when reacting with normal matter. They are not black holes either, because black holes end all activity happening around them, and they are visible as well. At least they could be directly detected with proper equipment. As for its behavior, this is purely theoretical, but dark matter couldn't sit on anything. It would pass through everything. It would go straight through a table, below ground, deep into the Earth's crust, and will shoot out to outer space. Dark matter particles are what scientists call WIMPs, weakly interacting massive particles, which are 10 to 100 times the mass of a normal proton. They are named that way because they just don't interact with any other matter. But don't assume that dark matter is made of just one particle. Assume that it is like ordinary matter. Two sides of the same coin, basically, but one side is invisible. The last thing that we can assume about dark matter is that there is a lot of it. It is probably made up of an unknown, complicated, and exotic particle that doesn't interact with light and matter in a way that we expect, but we can't really tell or be sure because all of this is theory. Now, moving on to dark energy, things get even weirder. Dark energy is strange and mysterious. You can't detect it, you can't measure it, but you can see its effects clearly. In 1929, Edwin Hubble examined how the wavelength of light emitted by distant galaxies shifts towards the red end of the electromagnetic spectrum as it travels through space. Faint, more distant galaxies show a large degree of redshift, with closer galaxies not so much. That is because the universe itself is expanding. Wavelengths of light stretch as the universe expands. That expansion is accelerated over time. Expansion means we get more space. More space means more dark energy, as it is intrinsic to empty space because it is what holds it all together. Without dark matter and dark energy, everything would fall apart and drift away from each other as gravity just won't hold. Dark energy is a stronger form of energy than anything else we know. Energy from empty space itself is bigger than everything else in the entire universe combined, except for Lizzo. There are multiple ideas about what dark energy might be. The first concept is that dark energy is not a thing by itself, and it is just a property of space, as empty space isn't empty. It has its energy and ability to generate more space while staying active. The second theory is an idea Einstein had in 1917, the concept of a cosmological constant, a force that counteracted the force of gravity. The problem is that trying to calculate this force is an act even worse than dividing by zero. Results have confused scientists and researchers even more than how they previously started. The third theory is that empty space is full of temporary virtual particles that spontaneously and continually form from nothing and then disappear into nothing again. The energy released from those particles could be dark energy. Our final concept is that dark energy could be an unknown kind of dynamic energy fluid of field that permeates throughout the entire universe and somehow has the opposite effect of gravity. Dark energy could potentially cause a huge rip in the universe as it expands violently and causes the stars and atoms to become unglued. But in a way that defies logic, the universe would fall apart without dark energy. There are things that we know, and there are things we don't know. The scary thing is that there is what we don't know that we don't know. Today, there are telescopes that are currently trained on locations where we think dark matter density could be the highest. An unexpected signal was picked up recently, but scientists are still not sure what it is yet. Only time will tell. There is also the Large Hadron Collider, which scientists hope will produce a dark matter particle that can be observed or studied. Space telescopes as well might detect the gamma ray signatures coming from dark matter collisions. In fact, the Dragonfly 44 galaxy was detected, which is said to be a 99.99% dark matter galaxy. The reason behind the theory is that there are so few visible stars in the galaxy, but it holds a massive signature that is far too great for the amount of stars we can see. The only explanation is that there must be something else there that is leaving all this signature behind. Dark matter. The fact that we can deduce something that we can't see is a tribute to the brilliance of the human mind. One intriguing but purely speculative theory is that dark matter was the cause behind the extinction of dinosaurs. As the solar system revolves around the galaxy, it does a little carousel as it moves up and down. The proposed idea is that every time the solar system moves through areas with high concentrations of dark matter, sometimes it dislodges some parts of the outer layer of the solar system. These periods have a higher probability of having cataclysmic events, which is what is suggested happened during the extinction of the dinosaurs. The meteors that came the Earth's way were sent off as a result of dark matter interference with the solar system and subsequently ended an entire species and gave way for the mammals to thrive and eventually gave humanity the way to take over the Earth. But we can only have the Earth because as it stands today, the universe is dominated by the dark side. Well, there you have it. What are your thoughts about the fascinating concept of dark matter and dark energy? Are you terrified of them or are you excited about the possibilities of what they could mean? If you made it this far, make sure to like and subscribe. It helps us out a lot. Leave a comment about what we should discuss next. See you in the next one.